Hi guys, I want to walk you through how to complete the chart here about loudness or sound level in decibels. If you have not yet watched the Ed Puzzle video on this, go ahead and do so now and then return. So the first thing we need to talk about is the unit. The unit is a decibel. So I believe in the video they talk about where that is derived. Deci meaning 10, bell meaning Alexander Graham Bell, who invented what? The telephone. So that's the first thing to recognize, that it is a tenth of a bell. So if we have, say, 10 decibels, that's going to be one bell. The other thing to note, and the more difficult thing, is you need to find your log button on your calculator. And usually it's the log button, and then it has like the second e to the x up top, or 10, I'm sorry, 10 to the x, I believe it is. That's above it. That's the button that we're going to be using interchangeably, going back and forth between how many times louder it is, the intensity of that sound, or the actual unit in bells, and then eventually decibels. So go ahead and find that button. So since it's a logarithmic scale, it's really that exponent that is going to be the important part of this. So just how this chart is kind of looking at, so if you have, if it's not labeled clearly, but if this was like column A and B, column A is the initial loudness, and then we're increasing the loudness to whatever it is at B, the final loudness. Column C would be the change in the loudness, how many decibels louder. So if it's a difference of 10 bells and we start at 20, the next loudness would be 30. So if it's 30 decibels, how many bells is that going to be? Well, since decibel is a tenth of a bell, simply divide by 10. So that's, the difference is going to be 10, so it's going to be one bell different. So to see how many times louder that is, we're going to use that second log feature on your calculator. So essentially what that button is going to do is going to do 10 to the first power because it's one bell. So 10 to the 1, that's pretty easy. It's going to be 10 times louder. So if we complete the next line, again, starting at 20, we have a difference of 20. So 20 plus 20, good job, is 40. So that's a change of 20 decibels, which is really 2 bells, because 2 divided by 10 is 2. So again, to see how many times louder that is, we're going to do 10 to the second power, or that second log button feature. So that's going to give us 100 times louder. So it's pretty easy as you deal in whole numbers of bells. So go ahead and go through the remaining section of the chart using that same idea. If you need help, refer to the answer key that's in Schoology. All right, so now that you've done that, if that was a little bit too quick for you, pause the video and then come back to it. So going now down to the 50 and the 51. So, or sorry, 50 and 53. So we go from 50 to 53, that's a change of 3 decibels, which again, it's a decibel, so a tenth of a bell. So we're just going to divide that by 3. So it's going to be 3/10 of a bell. So the same process, it's just not going to be whole numbers to plug in. So I know with my calculator, I have the cheaper version. I have to hit 0.3 and then I hit that second log button. You might have to hit the second log button and then 0.3. So it's just going to be 10 to the 0.3, which will give us about 1.995, I believe. And that's going to be about 2 times as loud. So then again, going to the next one, we're now working backwards. So we don't want to know what 10 to the some power is. We already know what that number is. So we're going to have this kind of equation. 10 to the x. X is what we're trying to figure out as far as the number of bells. So we know it's going to be twice as loud. So this is where you're going to use the log button. So you just type in 2 or log 2, depending upon the version of the calculator you would have. And it would give you a different, if something is twice as loud, it's going to be 3/10 of a bell difference. So then working backwards, if we have 0.3 bells, that's going to be 3 decibels. And if we started at 55, we're going to go to 58. So go ahead and try the next two on your own. Pause the video, and you can check your answers with the answer key in Schoology. So hopefully you were okay with the chart. If you have any questions, feel free to Schoology message or email me, and I'll get right back to you. So now what if we have not just increasing the volume, but we're increasing the number of speakers that you have? With headphones, you have 2 speakers. In cars, sometimes you have usually 4 or 5 or even more. Same thing with any kind of audio setup for TVs. You have several speakers, so you want to see how loud that is. Or it could just be multiple devices of things, multiple lawnmowers, trucks, and you want to calculate the loudnesses of that. So it's going to add same thing on that logarithmic scale. So it's not just going to be adding 1 plus 1 equals 2. It's going to be a little bit different. So in this first one, we're basically going to be doing like we did before. It's like A, B, and C columns. So 95 plus 95 is not going to equal 190. It's going to be something else. So what we have to do is I'm going to kind of test your understanding here, is 10 to the 9.5. And again, it's 9.5 because we have 95 decibels, and we need to be measuring in bells. So we're going to add that to the other loudness, 10 to the 9.5. Again, it's 9.5 because it's 95 decibels. And we need to find out what that total loudness is, and that loudness is the exponent, so that's the x part of it. So in your calculator, you could just type in 10 to the 9.5. Again, that second log feature is probably the easiest way. And then when you add them, you're going to get a huge number. We don't want that huge number. We don't want what 10 to the x equals. We just want what x equals. So that's where you're going to hit, not second log, but just the log button. So when you do that, it should come out to be x being equal to 9.8. Well, everybody knows 9.8 is gravity, right? What a coincidence. That is just a coincidence. This has nothing to do with gravity. Loudness is not directly related to gravity. So if we have this 9.8, that's 9.8 bells, which is going to be equal to 98 decibels. So this is a case where 95 plus 95 will equal 98 because we're looking at a different scale. It's not a linear scale. So for the next one, it's the same kind of deal where we kind of break up the chart here. The work is on the right and the problem's on the left, where we're looking for this missing value. We know we have one sound source that's 20 decibels, adding to something else that's making it 23. So we solved the same way as we did before, except we're just going to have to do some subtracting. So 10 to the 2.0 because it measured in bells, plus 10 to some missing loudness in decibels, or that would be in bells. And that's going to equal 10 to the 2.3. So you would just do 10 to the 2.3 minus 10 to the 2.0, and that's going to equal some huge number. We don't want that huge number. We want to know what the x is, because that is the loudness in bells. And in this case, x is going to turn out to be 2. I think it's like 1.999 something. So we can round that to 2. So 2 bells is going to be 20 decibels. So then you go ahead and do the same thing for the bottom of that chart. Again, if you have any issues, take a look at the answer key in Schoology. If you cannot get the calculator functions figured out, please send me a message and I'll send you a calculator tutorial back. Okay? Have a great day.